let us start with convolutional neural networking and recurrent neural networks, that is unit number 4 of deep learning techniques. Start with the basic introduction. Neural networks is nothing but a network that consists of interconnected nodes in number of layers, like a human or animal neural system, where each node resembling a neurons and edges resembling synapses. See, a neural network is a network which consists of a set of computational rules for passing input data from the network input layer to the network output layer, and each edge has an associative weight. So whatever the input data that will be passed to output layer through an edges, each edge has a specific weight. In other words, we can say that artificial neural network is a collection of artificial neurons are arranged in such a way that they can send and receive information between each other. Whatever the data we have, it may be images, handwritten digits, or given input to the computer in the terms of artificial neural network, which processes those data elements in such a way with the goal of producing required or desired output or desired result. So in many majority of cases, our target is to have producing accurate result. So input element will be converted into output with the help of intermediate layers is said to be a neural network. It uses artificial neural networking. Next, what is meant by convolutional neural networking, CNN? Very important question. Convolutional neural networks. In simple words, we can say that in order to identify a specific image or to recognize a specific image by processing whatever the images we have in the terms of a pixel data is said to be CNN. Convolutional neural network is a kind of network architecture for deep learning algorithms and is specifically used for image recognition and the tasks that involve processing of pixel data. As you know, pixel is nothing but a picture element. Every image consists of number of pixels. We used to see 1024 by 768, 800 by 600, 1200 by 1000. All these are come under pixels. A CNN is a type of deep learning neural network architecture commonly used in computer vision. Computer vision is a field of artificial intelligence that allows a computer to understand and interpret the image or visual data. Whatever the data we have given, that information is going to be understood and produces a required outcome. For example, pixels of images fed as input to the machine, where we have input layer. Input layer will be connected with a number of hidden layers, and then output layer we can have dog, bird, cat, etc. Here our target is to identify this particular picture is a bird. So a convolutional neural networking, CNN, is a feed-forward neural network that is generally used to analyze the visual images by processing data with a grid-like topology. It is also called as convolution network, called ConvNet. It is used to detect and classify the objects in an image. See, flowers of two varieties, orchid and rose. We have input layer, set of hidden layers, output layer, identifies the flowers into two categories. These network can handle wide range of tasks involving images, sounds, text, video, graphics, animations, and other media. See, this is the input data. It's a kernel, convolution layers. See, pooling. Pooling is nothing but grouping, combining. Flatten layers, fully connected layers. Finally, we have an output probability distribution, horse, zebra, and dog. What is convolution? It is a process of combining two functions to produce output of other function. See, whenever two functions are combined together to produce output of other function is said to be convolution. The input image is convoluted with applications of filters in CNN, resulting a feature map. I told you feature extraction, feature classification, feature prediction in previous sessions. Filters are the weights and biases that are randomly generated vectors in a convolution network. Many filters can be created. Each of one catches a different aspect from the input. Kernels are another name for filters. See this generalization of deep learning model architecture. We have input layer of artificial neurons, what you call it data. Hidden layers of artificial neurons, that is dense or fully connected, convolutional or neural network, recurrent network. Output layer of artificial neurons, which is called as predictions, which determines abstraction of layers 1, 3 plus. Internally, hidden layers may have multiple number of components. Already I told you, these are the hidden layers. Multiple number of hidden layers exist. And finally, we are producing an output layer that is of artificial neurons in the terms of predictions. Sometimes they may ask you in the terms of essay question as well, in the terms of a problem. In CNN, every image is represented in the form of an array of pixel values. Consider this is the real image of a desert called 8. If I'm going to represent that 8 in the terms of a grid, called 6 by, see this is a grid 6 by 5 represented in the form of an array. Here digit 8 is represented in the form of pixels, zeros and ones. See this, whenever the presence of 8, we are going to keep 1. Whenever the presence of 8 in a grid, we can say this is 8 in the terms of 1. Otherwise, we are going to have a 0. That is, pixel values are represented in the terms of zeros and ones. See this, in the case of leftmost corner, we don't have any presence of 8, called what you call a number. That's why we represent that element as a 0. The convolution operation forms the basis of any convolution neural networks. Let us understand the convolution operation using two matrices A and B of one dimension. A is equal to 537, 597, B is equal to 123. In convolution operation, the arrays are multiplied element-wise and the product is summed to create a new array which represents A into B. This is A into B. The first three elements of the matrix, these three elements of the matrix are multiplied with elements of matrix B. The product is summed to get the result. This procedure will be continued. See this, A into B, 532, 597, 123. So I'm going to multiply 5 into 1, 5, 5 into 1, 5. 3 into 2, 6. 2 into 3, 6. That is totally 6 plus 5 is equal to 17. Sum the product called as 17. That is A into B is 17 first. Next element 3, 2, 5 will be selected. 3, 2, 5 will be selected. 3, 2, 5. 3 ones are 3. 2 twos are 4. 3 2 twos are 4. 5 threes are 15. 15 plus 4, 19. 19 plus 3, that is equal to 22. 22 will be executed. Summing of the next three elements from the matrix A or multiplied by the elements of matrix in B, then the product is summed up. This process continues until convolution operation completes. See, if the question is, what is meant by convolution neural networks? Explain with an example. You have to write initial diagrams, convolution neural networks, and also we can have example. How does CNN recognizes images? Consider this is the image for the symbol slash. This is called as a backward slash. And this is the symbol for forward slash. The boxes that are colored represents a pixel value 1 and 0 if it is not colored. When you press backslash, below image gets processed. See, whenever you press a backslash, immediately this particular component, this one, and 1, 2, 3, 4, if we consider 1, 2, 3, 4, 1 and 4 will be activated. When you press forward slash, in the terms of 2 and 3 will be activated with above image, whatever. If you consider these are the 4 boxes, each box is having 1, 2, 3, 4. In the case of backward slash, 1 and 4 will be activated, whereas in the case of forward slash, 2 and 3 will be activated and processed. This is another example to depict how CNN recognize images. See this is an image, this is a real image. I'm going to convert this real image into equivalent grid in the terms of array of pixels with black and white pixels. Presence of a particular activity represents black color, otherwise empty. This diagram will be converted into zeros and ones, image represented in the form of matrix form of values, matrix form of numbers. As you can see from the above diagram, only those values that are existing in the terms of ones are representing exact diagram. Next concept is representation learning. See, very important topic, convolution neural networking. Convolution neural networks, CNN, how CNN works. With example, next one is representation learning. See, whatever the activities that are produced in the case of machine learning is to produce an outcome that is in the form of understandability, what you call interpretable, incorporate latent features, and also it can be used for transfer learning. See, representation learning is very important area of machine learning, which automatically discovers the feature patterns in the data. See, without having any kind of explicit mechanism, a technique that automatically discovers the feature patterns in the data is said to be representation learning. When the machine is provided with the data, it learns the representation itself without any human intervention. See, our target is to produce the required outcome without having human intervention. Whenever human intervention exists, that may not be come under artificial intelligence or learning systems. What is our goal? Our goal is to produce an outcome without assistance of human being. And I told you in the first unit itself many times, machine learning is a type of artificial intelligence that always learns from the experience without explicit programming. A machine that is adapted to the new situations is said to be machine learning. The goal of representation learning is to train machine learning algorithm to learn useful representations, such as those that are interpretable, understandable. We are going to include latent features. It can also be used for transfer learning. In other words, we can say that representation learning is a class of machine learning approach that allow the system to discover the representations required for feature detection or classification from raw data. See, first one is you need to collect it, detect it, classify it, and then predict or classify. When you have a raw data, our target is to produce our representation in the terms of feature detection or classification. The requirement for manual feature engineering is reduced by allowing a machine to learn the features and apply them to a given activity. I told you in the previous point also, whenever we have a raw data, without having human intervention, without human support, a machine is going to perform its activity. Representation learning works by reducing high dimensional data to low dimensional data, making it easier to discover the patterns or anomalies. Anomalies is nothing but mistakes, problems, while also providing a better understanding of data's overall behavior. So our target is to produce or identify its overall behavior. We must employ the representation learning in order to ensure that the model provides invariant, untangled outcomes in order to increase its accuracy and performance. Again, representation learning can improve the model's performance in three different learning frameworks, as you know, that is supervisory learning, unsupervised learning, semi-supervised learning. See this Venn diagram that distinguishes traditional family from the representation learning family of machine learning techniques. See, this is a traditional machine learning approach where we have a linear or a logistic regression, Bayesian trees or random forest, SVM called a support vector machines. Whereas representation learning is considered, there is ANN, artificial neural networks or deep learning. This is a traditional machine learning and this is representation learning. Representation learning consists of two parts, artificial neural networks and deep learning. Now move on to the same known component also, that is supervisory learning, unsupervised learning. See, whenever we have a known labeled training data set, we can produce an outcome what you call supervised. There is known name or labels, known labels exist, that is called as unsupervised. Supervised learning is a type of machine learning in which machines are trained using well-labeled training data. On the basis of the data, machine can predict the output. In general, supervisory learning always produces an exact output because all the labels are known. See, labeled data. This is a labeled data. And the labels are hexagon, square, triangle. This is a model training. And these are the predictions which produces the test data outcome. Here, this is the test data. Predictions will be square because we have no label data set, and triangle. In a supervisory learning, the training data provided to the machines work as a supervisor that teaches the machines to predict the output correctly. It applies the same concept as student learns in the supervision of a teacher. For example, whatever the component we have, those components can be identified with the help of training data, labels or known labels in order to predict, in order to produce our outcome called supervised. Unsupervised. The name itself defines unsupervised learning is a learning model where we don't have any kind of a labeled training data set, in which models are not supervised using training data set. Instead, models itself find the hidden patterns and insights from the given data. That means it can be compared to the learning which takes place in the human brain while learning new things. See, we don't, if you are going to learn, already existing information may be retrieved, existing information may be verified, is said to be supervised because everything is no label. Whereas If you're going to learn a new thing, we don't have any kind of existing known elements. Unsupervised learning is a type of machine learning in which models are trained using unlabeled data set and they are allowed to act on the data without any supervision. See this, we have unlabeled data, we don't know anything. Interpretation, algorithms are applied, processing, and produces an outcome in the terms of these are dogs and these are cats. This is, whereas in the case of this, we have everything is known labels, test data to produce an exact outcome. This is supervised and unsupervised learning. If you want to write, if sometimes the data may contain some known labels, some of the data may not contain any kind of known labels. In such a case, we are going to utilize a system what you call semi-supervised learning. If you're going to use even reinforcement, I told you in previous sessions, that is supervised learning, unsupervised learning, and semi-supervised learning, reinforcement learning. Next one, convolutional layers. Convolutional layers. Just now I told you, two elements are combined together to produce one outcome is said to be a convolution. It may be applicable at various areas. So, what is meant by convolution? Neural networks or convolution layers. In a CNN, what is CNN? Convolution neural networks. The major building elements are convolution layers. We have multiple number of layers. Each layer may have a separate functionality. One component represents abstraction of other components. This layer often contains input vector such as images, filters, such as feature detectors, and output vectors such as feature map. The image is abstracted to a feature map, also known as activation map, after passing through a convolution layer. The input is convoluted by convolution and then passed to the output to the next layer. This is similar to a neuron's response to a single stimulus in a visual cortex. Each convolution neuron only process the data. For a receptive field, it is assigned to. All fields may not be activated, only a specific field will be activated. Convolution is a grouping function in mathematics. Convolution occurs in CNN when two matrices are combined to generate a third matrix. See, meaning is common for every component. Two or more elements are combined together to produce a required outcome is said to be a convolution. In the convolution layers of CNN, these convolutions are used to filter input data and find information. Find information. And then these are convolution. Say this source pixel, convolution, that is a kernel, new pixel value, that is destination pixel, new pixel value, it's a destination pixel. Convolution layer consists of set of kernels, which are also known as a filter. What is a kernel? All these kernels are some kind of small windows, also called as patches, that scans across the image from top left to the bottom right. In the case of image processing or random scan, raster scan, any kind of monitor technology, the images are going to be scanned like this. Kernels are made up of weights which as a dense layer are learned through back propagation. There is a concept called back propagation. Kernels can range in size, but the typical size is 3 by 3. For a monochromatic MNIS TD set, this 3 by 3 pixel window would consist of 3 into 3 into 1 weight, what you call 9 weights, for a total of 10 parameters. For the comparison, we happen to be working with a full color RGB red, green, blue images. A kernel covering the same number of pixels would have 3 times as many weights, 3 into 3 into 3, that is totally 27 weights and 28 parameters. See this? When reading a page, of a notebook written in English, we begin from the top left corner and read to the right. Yes, dear. From this, we are going to read everything up to bottom right. Every time we reach the end of the row of the text, we progress to the next row. In this way, we eventually reach the bottom right corner, thereby reading all of the words on the page. In a similar manner, the kernel in a convolution layer begins on a small window of a pixels in the top left corner of a given image. From the top row downward, the kernel scans from left to right until it eventually reaches the bottom right corner, thereby scanning all of the pixels in the image. See, while reading your notebook or your material, we are going to start with the top and move on to the last. Then again start with the left to right, left to right. In this way, we are going to move on to last component, what you call right bottom element. In the convolution layers also, the same activity can be executed in this fashion. Next, in this case, we have the kernel occupies discrete positions across an image as it convolutes. Sticking with a 3 by 3 kernel size for this explanation, during forward propagation, a multi-dimensional variation of the most important equation, W into X plus B, is calculated at each position that the kernel occupies as it convolutes over the image. So 3 by 3 window, input X and weight W can be represented like this. See this? These are the kernel weights. These are the pixel weight. 0.01 into 0.53 plus 0.09 into 0.34, 0.22 into 0.06, minus 1.36 into 37. These values are going to be multiplied in the terms of Z is equal to W into X plus B. X consists of X1 and X2. W consists of W1 and W2. These elements will be computed to produce a required outcome. Convolution kernels have weights, input, and bias. A weighted sum of these is produced by using most important equation resulting Z that is passed through some nonlinear function to produce an activation. So convolution layer can have orders of magnitude fewer weights than fully connected layers. When you compare with the fully connected layers, we can have just fewer weights than the fully connected layers. As do not changes as convolution. Instead, they are shared across all of the inputs. They are going to change. They are going to share all of the input data elements. See this, how we are going to create W into X, W into X. This is 0.1 is a kernel weight and pixel input is 0.53. 0.1 into 0.53 plus this is the second value in 3 by 3 matrix 0.9 into this pixel input 0.34 and 0.22 into 0.06. In this fashion, kernel weights are multiplied with pixel input in order to produce required outcome. See, in this case also, see, you have to draw the diagrams if possible. For this subject, for our subject, diagrammatic representation is very important. That's why I have collected many of the diagrams from internet sources. These are the information. Sometimes all these diagrams are collected from internet sources. Some of the diagrams are from your textbook. So there is no exact information related with your syllabus in your textbook. That's why we have collected majority of information elements from internet sources. See this is a source pixel. Source pixel will be convoluted. See, in this way, this is a graphical image format. If it is a PowerPoint, it creates some kind of graphical image format. Then next three will be selected. These values are computed. New pixel values, destination pixel will be represented in the case of convolution layers. So very important question. Convolution neural networks representation logic. And this is very, very important. Convolution neural networks. I told you we can have multiple number of hidden layers. And when you give any image or a pixels of image fed as input, machine produces the final outcome. See this. These are flowers of two varieties, which produces two categories, identifies the flower, that is CNN. Remember, sometimes the question may be asked you in the form of discuss, CNN. So you have to perfect with acronyms also. Convolutional neural networking, RNN, recurrent neural networking, ANN, artificial neural networking. Okay. So this problem is very important. You have to use some problem, or they may ask you some specific problem. You can do it. Whatever the information it is, you have to take it. That can be placed in the terms of a grid. Same grid elements will be converted into in the terms of zeros and ones called pixels. And you need to calculate matrix multiplication in this way. And another component backslash forward slash. And third one is, this is the image. This image will be converted to black and white pixels. Those pixels will be converted into zeros and ones in order to produce outcome. Next one, representation learning. Already I told you, traditional machine learning is different from representation learning. ANN, deep learning are come under representation learning, whereas traditional machine learning is concerned linear or logistic regression, decision trees, random forest, support vector machines, and so forth. I told you three categories of approaches: supervised learning, unsupervised learning. Convolution layers, I told you, these are the major building elements in the convolution components, where we have set of kernels, how reading or performing convolution activities in the terms of diagrammatic and corresponding calculation in the terms of convolution. That's all.